All right. So the courses that this is this, not that one. This, where is it? I think it's this one. Come on. Mark all is absent. Okay. So we got Mr. No, am I in the wrong? These are guys from the previous. That's the only drawback. Right, I just have to. Let them in. Okay, 11. All right, let me let these gentlemen in. I think he's from the previous class. Get that student. Let me remove him. I don't know if that's. I'm just gonna. They're just gonna have to sit in. Okay, I'm not gonna worry about it for right now. All right. All right. Give me just a minute. I'm coming, guys. Okay, I think you can hear me. Let me. Oh, well, that's what I didn't want, but that's okay. Let me. Where is it? Oh, that's still going. Okay. Yeah, I should have just restarted, but that's okay. You live and you learn. All right, gentlemen. So welcome. Sorry, running late. My last class kind of ran long. So welcome. We got some of my students from my previous class are still on the call. They just haven't hung up, and I'm hesitant to reboot everything because I feel like it's going to be disruptive. So I just have to remember to do that next time. Let me see as far as announcements go. So the main thing is that there's two main things that I'm expecting of you all from like a day to day is at each of these sessions you're getting your attendance credit by getting into the Zoom. So if you're in the Zoom now, that means I had you on my roster and you're good to go. And then the other thing is that you make sure that you're submitting your assignments via MyMathLab promptly, right? So we've already had one set of assignments due, right? It's a small late penalty, so if you missed it, just don't worry about it. Just as long as you go ahead and get started now, you're gonna be fine. It's not really gonna affect your grade. And honestly, if we're in the end of the semester and you're like close between one letter grade or another, I'll probably just give you those points, right? So I'm not, I don't want you guys stressing about a late penalty on those first assignments, right? Because it's almost non-existent for right now. But as long as we going forward, you get started now and going forward. Hopefully, you all are finding or gaining access to MyMathLab. There are several ways that people are gaining access. Like my recommendation is to go directly to the site through the link in Blackboard. And for right now, you guys should have the 14-day temporary trial active. I still haven't heard back from my colleagues as far as the price reduction and purchasing full access. But if you want, you could also just go ahead and just purchase the full access directly from the site instead of doing the trial. I've had some students purchase the book new, like pretty much from the Morehouse bookstore. And I know I had at least one student where his new book came with an unused MyMathLab access code. If you have to use a book voucher if you have to use a book voucher to purchase your materials, you can still, if you purchase it from the bookstore, you can actually just purchase just the My MathLab access code, and you can use your book voucher to purchase that. If there's any kind of delay in payment or any kind of delay for right now, you definitely want to just go ahead and use the 14-day temporary trial. Let me check Zoom one more time. I usually only do 2 waves for the Zoom, for the waiting room. Let me go ahead and let him in. And update my attendance. Oh, I already had him. I guess he got booted. We're only missing one. And this is kind of what happened last time. I guess he'll find his way. Okay, it's not too bad. You guys are a lot more manageable. My class before you guys it felt like 30 students. It was a lot of students, but it's okay. Yeah, right. And so again, as usual, if you have questions about anything, feel free to unmute yourself or type in the chat. I am monitoring the chat in Zoom, and these sessions are being live streamed on my YouTube, so you can always go back and watch these. There are 2 main playlists I've created that you guys need to be aware of on my YouTube channel. One playlist has all the pre-recorded lectures for the semester. So like, for instance, when we start making our way through these sections, anything that you see me saying regarding these sections, I've already put it in my pre-recorded lectures. It's the same material, have the same ideas and concepts and strategies, essentially. What was the other thing? I was trying to get the other thing out, but it's okay. That's okay. So, the playlist that you need, right? So you have the pre-recorded lectures, and then the other playlist that you need. Basically, there's a second playlist that's like I'm dumping all of my live sessions from this semester, from fall of 23. There's another playlist where I'm pretty much putting all of those. So if you ever want to find either our session, and you can also kind of sit in on my sessions with other students if you want, like you can watch those. And a lot of you guys are talking about the same thing, but I made one playlist where I'm putting all of my sessions from the fall of 23 in that playlist, right? And again, so if anything is not clear, feel free to either unmute yourself or type in the chat to get my attention and we can talk about it. And let me say this as well. So pretty much from here on to the end of the semester, our rhythm is going to be, we pretty much will do like 3 weeks of of content, and then that 4th week are going to be exams, right? So for instance, this is week number 2. So we did 2 sections this week because we're just trying to play catch up, but generally speaking, we'll do 1 section every week. So this week is really supposed to be just 1.2, but we're going to be doing 1.2 today. Next week will be 1.3, and then the week after that is going to be exam 1 over sections 1.1 to 1.3. Right. And then basically, again, 3 weeks of content, 1 week of lecture, 3 weeks of content, 1 week of lecture, all the way until the end. Okay. All right. I think that's the long and short there. So again, we're going to be continuing chapter 1, our discussion on graphs and functions. And today we're going to be looking at section 1.2 lines. Some objectives here. Sorry, I bit my lip in the night. And so it's hard for me to talk now. It's like I kind of have a mini lisp, but it's like, because my mouth is in pain and I'm just trying to get around it. It's weird. It's like I nurse it during the day and then I check on it the next day, and I don't know. It just seems like it just keeps getting caught in my tooth or something. I don't know what's going on.
Excuse me, Teach.
Yes.
I'm sorry. I just now joined in from. I sent you an email about. Did you record the orientation that you did for this semester already in that playlist?
Okay, yeah, okay. Every session so far has been recorded. It is in that playlist. If you're just joining us, just kind of remind me towards the end of class today so I can mark you as excused for the first couple of days. And
yes, sir.
And the main thing is over the next couple of days to at least get the temporary access to my math lab, right? So just kind of remind me towards the end of class, and we can make sure that you're taken care of.
All right, thank you.
So some objectives here for section 1.2 lines. We like to find the slope of a line. We like to write the point slope form of the equation of a line, write the slope intercept form of the equation of a line, recognize the equations of horizontal and vertical lines, recognize the general form of the equation of a line, and find equations of parallel and perpendicular lines, right? So we really only have about 35 minutes from this point together. So we'll do the best we can with this list, but whatever we don't finish together, I do expect you all to use my pre-recorded lectures. Watch those, take notes as if you're in class, write down your questions, and you can do that. So right. And then the other thing I was trying to say was so again, these lectures are available for the entire semester, right? So you don't even have to wait on us. Also, all homework and all quizzes for the entire semester are available right now on my math lab, right? So what that means is that you could go ahead and watch the lecture, take the notes, and you can actually get started on any assignment. You don't have to wait for us to be live. The only thing that you will be waiting on, I did a staggered or a scheduled release of the exams, right? So exam 1 is not scheduled to release until we hit week 4. And then you can earn full credit for the 7 days. And then with all of our assignments on my math lab, we get unlimited attempts. The system is set to take our highest score. And all assignments have a natural or inherent extension already built into them, right? So you can, what I mean is you can submit any assignment late, but if you submit any assignment late, there's a 10% late penalty. So the highest you can earn on a late assignment is 90%. All right, okay. And again, with those first couple of assignments, if you're submitting it late, don't stress about that late penalty. It's really, really small. So it's not really going to affect you. As long as you're logging in now and moving forward, being prompt going forward, you'll be fine. And then, yeah, okay. So let's kind of go ahead and get into the content here. So we have some definitions. Since the graphs of first degree equations in two variables are straight lines, these equations are called linear equations. We measure the steepness of a line by a number called the slope, right? So can anybody describe to me, like, where in your everyday life might you encounter lines with a slope? Like where might you encounter something that's steep or something that has a slope in your everyday life?
A hill.
A hill, right? Like you guys probably, maybe like if you walk into the cafeteria, like if you're on campus, walking across campus, Georgia is infamous for its hills, right? We have all these hills all over the city. So the more steep the hill is, the more the incline, the harder it is to climb. All right. I know when I would run the Peachtree Road Race in the summertime, there's this huge hill at mile like either 3 or 4 out of the 6. It's called, I think it's called Heart Attack Hill. I hope that's not what it's called, but it's this really steep hill late in the road race, right? So you're climbing, and I think the hill is like, it's either half a mile to 3/4 of a mile, something like that, all uphill. You're like, geez. But that's Atlanta. So you start to learn how to navigate hills and things of that nature. You also might experience something with a slope, like when you're the entrance and exit ramp onto highways. I think one student said the stairs on the staircase. If the slope was too steep, then it would be difficult to climb the stairs, and eventually it would turn into a ladder. Some students said mountains, right? Right. So these are things that have slope, right? And again, the more steep it is, the greater the slope. Okay. So this is a pictorial representation. So it says the rise is the change in y coordinates between our points, and the run is the corresponding change in x coordinates, right? So given 2 points, with this first one, notice that as we trace this image from the left to right, the graph goes up. So we say that this has a positive slope, right? Positive slope. With the second image, as we trace it left to right, the graph falls. So this is an example of something that has a negative slope. All right, this has a negative slope. What? Why does that say 1214? My computer is like bugging out. It totally says 1214. Let me see something real quick. Yeah, that's trippy. Why is it doing that? I don't even know. Okay, well, all right. So again, slope is the rise over the run, or the change in y over change in x. Okay, so let's see the next slide. So the slope of a non-vertical line that passes through the points P and Q is denoted by M and is defined as follows. So the slope is the rise over the run, which is our change in y over change in x. So that's y2 minus y1 over x2 minus x1. The slope of a vertical line is undefined, right? Okay, so with this, So hopefully you all have like a homework notebook where you're keeping up with all this material. The name of the game for at least college algebra, and if not all of your other courses, is basically your ability to be organized and have proper time management, right? If you're just kind of like passively sitting by and you're not like taking notes or you're not keeping log of your homework, then you're essentially wasting your time, right? Your time and your money, especially your money, right? Because the only way, not the only way, but the the recommended way to kind of like process this information again is to be neat and organized. So again, hopefully you have a notebook where you have three main items. One, you have a formula sheet. So every time you come across a formula, like such as this one, you update your formula sheet. Two, you have a copy of the lecture notes, right? So all the stuff that you see me writing, I make a copy available. You can access it on Blackboard in that main folder. And then three, you have a copy of your homework assignments as you work them, right? So like in your homework section, you have the section of each, you have the header for each section. Like for instance, this is 1.2 lines. With each homework question, you have a copy of the original question. Below the copy of the question, you have any supporting work, right? You have your supporting work. And then whatever conclusion you arrive to, you put your final answer in a box, right? So the better you're able to kind of keep your notebook up to date with this content, again, with your formula sheet, your homework, and your lecture notes, the better you're able to organize that, the easier it's going to be for you to process this information. If you're not keeping track of what you're doing, you may or may not do the homework. Your ability to commit it to memory is going to be reduced. And I also want you to kind of be aware, like, don't get too lax, right? Even though right now our exams are like pretty much on your own, you're not going to be in a testing environment, so it's like an honor system. Potentially, you could find yourself somewhere where you're going to be taking these tests in a testing environment. I know some of my students in the spring, the final exam was in person, right? So even though like I essentially ran the course like an online course, we had to do an in-person department-wide final exam, right? So I just don't want you to be lax and like kind of just shirk off this information because we're not doing a testing environment. That doesn't mean you won't find yourself in the testing environment being responsible for this information. Okay, so as long as you kind of like have your notebook, you're being neat and organized, you're staying up to date, you should be fine. That's the long and short there. Let me see something here. I don't see him, so I'm not going to worry about it. And there's only one person that's missing. All right, let's keep going. So, yeah, so hopefully you have a formula sheet. You're updating with formulas such as this. And let's do this on the next slide. So in this example, we're asked to sketch the graph of the line that passes through the points P and Q and find and interpret the slope. Now, let me see if I still have this saved. See, can I paste? No? Okay. What I'll do, if I go to my reactions, I'm going to screenshot. Right here. I want a copy of these guys. Okay, let me copy and delete, and paste. Allow the paste. That's okay. Paste. Nice. Okay. All right. So we're gonna let the clappy hands, right? So in Zoom, you'll see reactions like you see here on the screen right now. We're gonna let the clappy hands represent quadrant 1. We're gonna let the thumbs up represent quadrant 2. We're gonna let the heart represent quadrant 3. And we're gonna let the laughing emoji represent quadrant 4, right? So you'll see how we're gonna use this in just a moment. Let's copy. All right, so with this next example, let's see. So we're asked to sketch the graph of the line that passes through the points P and Q, and then find and interpret the slope of the line, right? So really quickly, if what quadrant is the point P in, right? You see the order pair 1, -1. If you feel like that's quadrant 1 in Zoom, you can use the clappy hands if you feel like that's quadrant 1. If you feel like P is in quadrant 2, you would do the thumbs up. If you feel like P is in quadrant 3, you can do the heart emoji. And if you feel like P is in quadrant 4, you would do the laughing emoji, right? So which quadrant is P in? Inside of Zoom, really quickly. Let's just take a few seconds. I see some laughing emojis. I don't know why that always makes me smile. It always makes me laugh. Like, it's so silly, right? I can get down with the laughing emoji, right? That means we're talking about quadrant 4, right? So if we start at the origin, right, we go right 1 and down 1, that puts us in quadrant 4. I can get down with that. Okay. Which quadrant is Q in? Right? If we go right 3 and up 3, I'm seeing a clappy hand that represents quadrant 1. I can get down with that. Any others? Any other takers or challenges? Okay. So we got at least one that's saying quadrant 1, right? And I think that makes sense, right? We go right 3 and up 3. So quadrant 1 looks accurate. Okay. So it looks like we're working in quadrant 1 and quadrant 4. So that's really the right hand side of the XY plane. So when I go to do my sketch, I'm just going to focus on the right hand side of the XY plane. Again, this is going to be a rough sketch. It's not necessarily drawn to scale. And we're going to go about here, right? So our positive X is in this direction. Our positive Y is in this direction. Again, it's not really drawn to scale. So let me see, 1, 2, 3, 4. If you're doing a rough sketch like this, it is a good idea for you. You want to try to be uniform with your spacing, right? You don't want these to be spaced differently, because then it's going to really disrupt things. If you want to be more precise, I would encourage you to use like graph paper. But again, I'm just doing a rough sketch. Let's see about. Let me see. Okay, I think we're okay. Space out a little bit, but that's okay. Let's get rid of this. Can we paste? Okay, that looks good about there. And let me get rid of this. Okay. Let's see. So point P, we said was quadrant 1. Right? No, sorry, I think we said quadrant 4. So if we go right 1 and down 1, that puts us about here. This is the point P, 1, -1. Okay. And then the point Q we said was quadrant 1. So we went right 3 and up 3. Right 3 here. Let me copy this. Copy and paste. Right. So we said 1, 2, 3. 1, 2, 3. That puts us about here. So again, if I was using graph paper, that would be better. But because this is like a rough sketch, then it could throw us off a little bit. But I think we're going to be okay. Something like this, approximately. All right. Sketch the graph of the line. Get something like this. And so that might pass through -3. But again, if I wanted to really be accurate with that, then I would use graph paper. Right. But I'm just trying to do a rough sketch. Okay. All right. So sketch the graph of the line that passes through this. Find and interpret the slope. So we have the graph. So then to find the slope, again, one of my mentors would say every time we use a formula, write it down. So since we're finding the slope, let's go ahead and use the slope formula. Slope formula is what? The rise over the run, which is the change in y over change in x. So that's going to be y2 minus y1 over x2 minus x1. And again, this is our slope. Another thing I like to do is whenever I'm given an ordered pair, I just like to label it off the rip, right? So like x1, y1, x2, y2. Okay. So now we're ready to submit these components into the formula. And the recommendation is with this next part, first is to replace each component with a blank set of parentheses, right? So we're going to say y2 minus y1 over x2 minus x1, right? And so now we can plug in the corresponding components. Our y2 is 3. Our y1 is -1. Our x2 is 3. Our x1 is 1, right? So hopefully it's clear that the blank parentheses, what they do is they help us to keep track of our signs. And namely is here, we have a double negative going on. So that double negative becomes positive, right? Without the parentheses, it's easy to miss that double negative. Sometimes students just ignore the sign, or, it just kind of goes haywire, right? So the blank parentheses, again, the intent there, it helps us to keep track of our signs so we're less likely to make mistakes when it comes to that, okay? So 3 plus 1 is 4. 3 minus 1 is 2. 4 divided by 2 is 2, right? So what we're saying is that the slope of our line is 2. And so what this means is that a slope of 2, what we're saying is that y is going to change by a factor of 2 for every time x changes by 1 unit. So y changes by 2 units every time x changes by 1 unit, okay? All right, so that's what a slope of 2 represents. Let's keep moving forward. Wait a minute, did I miss somebody? No, I think we're okay. All right, so here's a digital representation of what we just experienced, right? So we plotted the 2 points, connected them with a straight edge. The change in y over change in x was basically 4 over 2, which reduced down to 2. And here's the type version. And then again, the slope of 2 means that the value of y increases 2 units for every 1 unit increase in the value of x. Okay. Hopefully we're all aboard and we're not all bored. Again, if you have questions about anything, actually, let me check the chat. I've kind of been ignoring the chat a little bit. Yeah, I think we're okay. So yeah, if anything is not clear, feel free to either unmute yourself to get my attention or type it in the chat and we can talk about it. Okay, let's keep going. We have a little over 10 minutes, maybe a little bit closer to 15 minutes remaining. But again, it's gonna be over in the blink of an eye. Okay. So we have a few main facts about slopes of lines. One, scanning graphs from left to right, lines with a positive slope rise and lines with negative slopes fall. The greater the absolute value of the slope, the steeper the line. The slope of a vertical line is undefined, and the slope of a horizontal line is 0. Okay, I feel like those are pretty straightforward, so I'm going to kind of let them be. So here we have the point slope form of the equation of a line. If a line has a slope m and passes through the point x1, y1, then the point slope form of the equation of a line is given as such, right? So again, if you have your formula sheet, this is another formula you want to definitely update your formula sheet with. So now with this one, to me, I always remember this one by doing some manipulation. I like to start with the slope formula. With some minor manipulation, you can actually generate this formula, right? So let's see the connection. So if we start with the slope formula, which is our change in y over our change in x, and again, this is the slope. So with algebra, right? If we multiply both sides by that denominator, right? On the right-hand side, a number divided by itself is 1, okay? Yeah. And so then now at this point, we have equals y2 minus y1. If the left-hand side equals the right-hand side, we can actually flip the order. So we can write it as the right-hand side is equal to the left-hand side. All right, so that means we can do y2 minus y1 equals the slope times x2 minus x1. And then if we just drop the 2's, then we have our point slope formula, right? So all I started with the slope formula in green. I multiplied both sides by the denominator and dropped the 2. And then that's going to be your point slope formula, right? That's how I like to remember the point slope formula. So as we work with lines, there are 3 formulas that you definitely want to have ready to go. We've talked about 2. Let's kind of hold out for a moment until we get to the third one, and then we'll talk about the third one, and we'll showcase all three when we get there. So again, with this point slope form of the equation of a line, we typically use this whenever we're given a point and a slope, all right? We typically use this whenever we're given a point and a slope. Okay. So in this example, we're asked to find the point slope form of the equation of a line passing through this point with that slope, and then we're asked to solve for y. Okay, so again, the recommendation is every time we use a formula, write it down. If we're doing the point slope form, that's going to be y minus y1 equals m times x minus x1, right? That's point slope form. Again, we typically use this form whenever we're given a point and a slope. Okay. So now we were given our slope and we were given a point. So this is going to be our x1, y1. Okay. So then let's plug these components into our formula. So then we're going to have y minus y1, which is this -2. Notice my use of parentheses, equals our slope times x minus x1, which is this guy. Okay. So we have a double negative going on. So that becomes positive. And if we want to solve for y, if we have y plus 2, then we will use the inverse operation to isolate the y, right? So the inverse operation of plus 2 is going to be minus 2, right? So we would subtract 2 on both sides. Can anybody, what is this called again? What is this technique that I'm doing here with these blue arrows with the 3? What is that called? It begins with a D.
Distribution.
All right, we distributed the 3, right? That's an example of multiplication essentially over addition. Subtraction is just another form of addition. So if we distribute that 3, we're going to have y plus 2 equals 3x minus 3, okay? Again, if we're solving for y, we're going to use the inverse operation. So the inverse of plus 2 is going to be minus 2, right? So then we're going to subtract 2 from both sides. Right? Then we get y equals 3x. -3 minus 2 is going to be -5. Okay. So that was a showcase on how we started with the point slope form. And what this form at the end is called, that's the classic y equals mx plus b. That's called our slope intercept form, right? Let's see what we have on the next slide. Here's a type version of what we just experienced. Actually, I would like to do this one, but I'm actually going to leave this one as an exercise for you all, just in the interest of time. Okay. And let's take a look at this one. Give me just a moment. Oh, man, it always gets tough. Like when I get to you all in my next group, I'm getting exhausted because I kind of been like doing this since like 9 this morning. And I don't stop until almost 8:30 at night. So I'm almost talking for this. It's really 6 hours, but I'm on call for like 12 hours, and it's draining. Especially like my mouth hurting, and so I don't want to talk, but I have to. Let's see. So here we're asked to find the point slope form of the equation of line with a slope m and a y-intercept of b. Let's look at this one. So if we're doing a point slope form, and then we're also asked to solve for y. So point slope is going to be y minus y1 equals m times x minus x1. Okay. So then let's plug in what we've been given. Let's see. We have that the slope is m. Now, if the y-intercept b, can anybody tell me what's that ordered pair? Right? If the y-intercept is b, what's the corresponding ordered pair there? Anybody got that one?
A.
Try again. The y-intercept is b. What's the ordered pair? Like the x comma y. X comma y, right? So if the y-intercept is b, the ordered pair is going to be 0 comma b, right? X is 0 and y is b, right? And so what this is our x1 and our y1, okay? So now if we plug these different components in, we're going to have y minus our y1 is b equals our slope times x minus 0. Okay. A number minus 0 is going to be itself, right? So this is essentially gone. If we want to solve for y, we're going to use the inverse operation. The inverse operation of minus b is going to be plus b. So we're going to add b to both sides. Right, and I'm just going to put it here for right now. A number plus its opposite, these guys add to 0. My equal sign comes down. On the left-hand side, the only thing that remains is our y. Again, x minus 0 is just going to be x. So then that's going to be m times x. And then that plus b lingers. So this is a classic y equals mx plus b. This is the classic, again, this is called the slope-intercept form. Let's see what's in the next part. All right, so this is just a type version of what we just experienced. So that brings us to this. The slope-intercept form of the equation of a line with a slope m and a y-intercept of b is going to be y equals mx plus b, right? So this brings us to, again, every time we're working with lines, there are 3 formulas you essentially want to have ready to go. I'm going to write them out now. And again, all the stuff that you see me writing, you're going to receive a copy of it. You can access it in our Blackboard page. Open up that main link on the landing page, and then you'll see a link that says box link, and that's where the PDFs are. Okay. So when we're working with lines, there are 3 formulas that I think it's a good idea to have ready to go at your disposal. Okay. So the first one is the slope formula. That's the change in y over change in x. So that's going to be our y2 minus y1 over x2 minus x1. Again, this is the slope formula. Okay. Another formula that's a good idea to have ready to go when working with lines is the point slope formula. And that's going to be y minus y1 equals m times x minus x1. And then the last formula that's a good idea to have at your disposal is the slope-intercept formula. Slope-intercept. I'm just going to abbreviate it like that. And that's going to be the classic y equals mx plus b, right? So whenever we're working with lines, we typically flow between one or more of these formulas. Okay. Let me check the chat. We got a little over 5 minutes remaining, so let's keep going a little bit. Ouch. All right. Man, the weekend is just calling my name. I can just like be quiet and like scream at my games or like respond to something I'm watching on TV or hang out with folks or whatever. I just don't want to talk anymore. I just want to just kind of be quiet. But I mean, that's my job, so let's keep moving. All right, so here we're asked to graph the line whose equation is given by this, right? So I think earlier when we graphed our line, we made a statement saying to graph a line, we need at least 2 distinct points. Once we have 2 points, then we just connect them with the straight edge, right? So in this example, the line is given to us in the slope-intercept form, which is the y equals mx plus b. Can anybody feel confident in explaining how we use this y equals mx plus b to graph the line? How do we use this form to graph a line? And to me, this form is the easiest way to graph a line. Anybody feel confident in that? Going once, going twice? Okay. So let's see, how do we use this form to graph a line? So with this being y equals mx plus b, what we're saying is that our b, which is our y-intercept, is going to be 2, and our slope is going to be 2 over 3, right? So the y-intercept is going to be one of our distinct points, and then we use the slope to find the second point, right? Okay, so let's see it in action. Okay, so it looks like we're going to be working in quadrant 1, so I'm just going to try to focus on quadrant 1. Okay, and then I'm going to come over here. Okay. Let's see. If we can get to like 5 or 6, let me see. 1, 2, 3, 4, I think that's enough. That looks decent. Again, if I wanted to be more precise, I would just use graph paper. Let me copy and paste. Okay, that looks decent. That looks decent. Okay. Okay, and let me include some labels here. So we have like the origin here. And this is like 1, 2, 3, 4, 5, 6, 7. This is our positive X in this direction. This is our positive Y in this direction. 1, 2, 3, 4, 5, 6, and 7. Okay. So with this slope intercept form, I see the clock. We're going to get out of here in a few minutes. Our y-intercept is 2, so our first distinct point goes on 2. And then let me get a copy of this point. Okay. So then we use the slope to get to our second point. With the slope being the rise over the run or the change in y over change in x, the slope is telling us to go up 2 and right by 3. So 1, 2, 3, and that's our second point. So once we have 2 distinct points, in order to create the line, we connect them with the straight edge, and we extend this graph across the entire coordinate plane. Okay, and that's going to be the graph of the equation of the line, right? Again, the 2. So y-intercept, that tells us where to start. We use the slope to find the second point. Once we have 2 distinct points, we connect them with the straight edge. All right, so we did it by hand. Here's a digital version of what we just did. And I think this is where I've been stopping with everyone. Okay. Are there any burning questions before we go our separate ways? Anybody have any burning questions? Going once, twice. Let me go ahead and make a copy of this available for you all. The folder should be proper, so I'm going to go ahead and drop it there. When this bar finishes loading, you'll receive a copy of anything that you saw me writing. Let me see if there's any announcements. The main thing is, again, as long as you're getting into our Zooms, getting your attendance credit, and you're submitting your assignments on my math lab promptly, you're good to go. If you're just joining us and you kind of got a late penalty, do not worry about that late penalty for the first couple of assignments. Again, if we get to like the end of the semester and if you're close, I'll probably just give you those points. All right. I'm not going to hold that against you. And again, those are really, really small points. Like it's 10% of 10%. Right. One more time. Are there any burning questions before we go our separate ways? Going once, going twice. Let me check the chat. Forever hold your P's and rights. Okay. So if there aren't any burning questions, we're actually going to go ahead and end the session here. And from one beautiful mind to another, have a great weekend, gentlemen. I'll see you same next week, same time, same place. Take care. Peace.